Right now we're looking at how to write formulas for binary ionic compounds. Remember that a binary compound involves two elements, a metal and a non-metal. A compound is a substance composed of two or more elements combined in a specific ratio and held together by chemical bonds in a strong force. Familiar examples of compounds are water and salt, sodium chloride. Chemical compounds, this is just a reminder that you have to have 8 valence electrons, and that in ionic atoms gain or lose, or in covalent share electrons with the other atoms to become chemically stable. So this oxygen only has 6 valence, so it is going to bond with another group or another atom that is going to give it a total of 8, probably out of group 2. So sodium by itself is not stable, but because it has this one outer valence electron, but if it loses that outer valence, its underneath level is full and it is stable. Nitrogen has 5 outer valence electrons, but if it gains 3, it is going to be complete and stable. And aluminum has 3 outer valence, and if it loses those 3 because it's a metal, then its underneath energy level is full and is going to be complete. So again, just a reminder that you can sort of determine how it's going to bond. If it is a metal, it is going to lose electrons, so you just look at the group number and put a plus. So if it's in group 1, it's going to lose 1 valence, so its charge would be +1. All of the nonmetals are going to be negative, and remember that on that side you have to determine how many it needs, and how many it needs is going to tell you its charge number. So for example, if it's in the halogen group, it needs 1, so its charge will be -1. This is a bond between magnesium and oxygen, and so magnesium will bond with oxygen. Magnesium will give away 2 electrons that oxygen needs, and then they will all be stable. The same thing is true in sodium chloride. If you have sodium with 1 valence to give away and chlorine will take that valence, then you're looking at a sodium chloride ionic bond. Now, if you want to write binary ionic compounds, and again, binary just means a metal and a non-metal. The metal is always going to lose, the non-metal is always going to gain. And again, you can use their charge numbers across the periodic table to look at how they are going to bond. So I'm going to skip this and just go straight to writing guidelines for binary ionic compounds. So except for hydrogen, the metal, the one that's furthest to the left, is always going to appear first. You can look at each one of these and see that the metal is first, potassium, phosphorus, aluminum, and iron, followed by the nonmetal. Now, if you do have a hydrogen present, it's always last unless it is bonding with another nonmetal out of group 16 or 17. Then hydrogen will come first, like, for example, hydrogen chloride or hydrogen iodide. So the hydrogen always comes last unless it's going in front of a nonmetal. If they're both in the same group, the one that's at the bottom comes first. So silicon, for example, and carbon are in the same group, so you would write silicon first, followed by carbon. Bromine and fluoride are in the same group, so you would write bromine followed by the fluoride. So this is a very basic thing that you do. So the first step of ionic compounds is you write the metal, the symbol of the metal first, followed by its charge as a superscript, like aluminum is here. Okay, so Al is the symbol and its charge is +3, and super means above, so you write it just above. Oxygen, on the other hand, is the nonmetal, and it has a -2 charge, so it comes second, and then you write the charge. So all you do to write the formula is you take the charges and you crisscross them. So what was behind the aluminum now goes behind the oxygen, and what was behind the oxygen now goes behind the aluminum. So now the formula is Al2O3. So that means that it's going to take 2 aluminums and 3 oxygens to bond correctly in that formula. I'm going to try to switch the screen here for a minute. So I wanted to do boron oxide, so B and O. So if you write the name of the symbol of the metal first, that's boron, and it's in group 3, so its charge is 3 as a superscript. Oxygen is the nonmetal. It's in group 16, so it has a 2 as its superscript, and all you do is crisscross. So the 3 behind boron goes over to the oxygen, and the 2 behind oxygen goes to the boron. And if you took a minute and drew that out, you would see that it does take 2 borons bonding with 3 oxygens to get that formula B2O3. Okay, now we have barium nitride. So you write the symbol for barium first. It is in group 2, so you write that as a superscript. And then nitrogen is in group 15, so its charge is a superscript of 3. Now, all you have to do to write the formula is take the charge that's behind barium and drop it down, crisscross it, down behind nitrogen, and the charge that's a superscript beside nitrogen is crisscrossed and dropped down behind barium. So your formula is Ba3N2. And if you draw that out, hang on, I'm trying to get it to move here. You would see that it does indeed take 3 bariums to complete 2 nitrogens. Now, another way that you may see this, that you will see this, is in a chart like this. So all you have to do is cross the chart. So K plus 1 and Cl negative 1. If it has 2 of the same charges, you don't write those. So that becomes KCl. If you take K plus 1 and combine it with O negative 2 and crisscross those charges, you get K2O. If you take K plus 1 and cross it with P negative 3, you cross the charges, you get K3P. If you take K plus 1 and S negative 2 and you cross the charges, then the 2 drops down behind the K and you never write a 1. So K2S would be your example, your correct formula. And on it goes. Mg plus 2, Cl negative 1, you cross the charges, you get MgCl2. Notice that you just take the superscripts and drop them behind the other element. That's all you're doing. So they call that crisscross applesauce. Mg plus 2 and O negative 2 is just going to be MgO because you don't write 2 of the same charge. Mg plus 2 and P negative 3, when you cross those, you get Mg3P2. Mg plus 2, S negative 2, you don't write 2 of the same charges, so that's going to be MgS. Let's look at aluminum. Aluminum is plus 3 and chlorine is negative 1. So if you cross that, you're going to get AlCl3. Aluminum is plus 3 and oxygen is negative 2. So if you cross that, you're going to get Al2O3. If you take Al plus 3 and P negative 3, then that is going to become ALP, no subscripts because they're the same. And then finally, Al plus 3 and S negative 2, when you cross that, it's going to become Al2S. So again, just some little reminders here. You write the symbol of the metal, followed by its charge as a superscript, and then you write the symbol of the nonmetal, followed by its charge as a superscript. And then all you have to do is swap and drop or crisscross the charges and put them behind each other. So it's a very simple process, and you just remember that when you can, you reduce. So if you have 2 of the same, then you reduce those. just summing up a few things about ionic and crisscrossing. It occurs between a metal and a non-metal. Metals are going to lose their valence electrons and become cations, and non-metals are going to gain enough electrons to fill their valence level and become anions. Always crisscross valences and reduce to determine the formulas of ionic compounds. Do not use prefixes in the names anywhere, and ions form a crystal lattice. So that is it for writing ionic formulas. Pretty basic, pretty simple, and so now we're going to practice.